How does a bunch of stuff strewn around a classroom floor suddenly become a map of the ocean's surface? Well, to explain that, we're going to break this down and show you step by step how we got from here to here. First, let's start with some of the setup. First, get a big pile of boxy objects and scatter them around your floor. And next, you'll take a pair of carts and a super duper long pole, and on the pole you will mount 4 motion detectors spaced equally apart that are all going to be connected to a pair of Vernier's LabQuest 2s. Be careful of all your wiring, tuck it away so it doesn't interfere with the sensors, and clamp everything down so it's nice and solid and tight. Alright, here comes the techie part. Each Vernier LabQuest 2 will have 2 motion detectors, and they're going to be taking data at a rate of 2 samples per second for about 5 to 10 seconds. You have to turn on data sharing so you can get the data broadcast out to laptop computers. So we're going to say 3, 2, 1, press, and we're going to start walking on 2. Okay. 3, 2, 1, press. Cool. So here's one of the challenges. How do we get the data out to the students? Well, let's look back at the Vernier LabQuest settings. Do you remember the data sharing? I just give every kid that IP address and they type it into a web browser. Since we have 2 going at the same time, they'll just keep 2 windows open. Another way to approach this is to use Vernier's Graphical Analysis, and you would go to here to data sharing. And if your LabQuest don't show up on your Wi-Fi, then you just specify the source and type in the web address. And I want to make sure that my data is saved, so I label it in a way that will make sense. LabQuest A has sensors 1 and 2. LabQuest B has motion detectors 3 and 4. And so I keep track of that by naming the experiment or the project. And I come over here and I export the data. I'm going to download the data and save it with periods and put it in my Dropbox or my download folder and share it out with the class, or the class will individually gather their own data. Alright, let's start by opening Excel. Grab the 2 files, A12 and B34. It doesn't matter which one you keep as your main document, but one of them is going to get thrown away. Need to know that we're going to keep these 2 columns of data. These other 4 columns of velocity and acceleration data, those can be deleted. Edit, delete. And then we go over to the other sheet and we grab those 2 columns of data. Copy and paste. And now we have all of our data. Now what we measured is the depth away from the sensor. That's not going to help us talk about the elevation from the lowest point of the ocean. So we have to convert this data. We have to enter a formula over here, and all formulas start with an equal sign. We take the greatest depth, which is that amount right there, 1.061, whichever value for you on your chart is the greatest depth. You subtract that cell right there, B2, and it gives you an answer. So the height of the ocean floor is 0.023 meters at that point. You grab this corner right here, you drag it down to fill and repeat the formula. And so this spot here, the lowest point is 0 elevation. And then you similarly grab that corner again and drag it over 4 columns. And then you have your ocean floor elevations. From here you grab all your data and you do an insert and a chart, a surface, and a 3D surface. And that's how our 3-dimensional map is made. You can control click on this and open up a 3D rotation. The 3D rotation lets you see everything from different angles. You should bring the Y rotation up to about 45. And then you can move through the X rotations and get a better sense of your underwater landscape. What was that bit of math that we had to do in the Excel spreadsheet? Well, you're out there in the ocean in your boat, and your Vernier motion detector is detecting the depth of the water to the nearest object. But what we really care about is finding the height of the ocean floor. So what we had to do is we had to take the deepest point and call that the total depth, and then we subtract out the depth of the water, and that leaves us with the height of the ocean floor. So this project is great and it's amazing, and the kids learn a ton about bathymetry. The best part is it only takes about 3 seconds to set up the whole thing. I didn't get the idea myself. I got it from the Vernier website. A couple of middle school teachers named Ryan and Matt originally had their kids make a lake bottom in their classroom. What a great idea. It took many iterations. In this first year, we put all the motion detectors on a cart, and then we took all those depths and converted them to heights and built an ocean floor with wooden blocks. Then we took the whole thing out in the hallway and we put a laptop on a cart with 2 motion detectors. This kid here had to become part of the landscape, of course, and then we brought the whole thing into Excel. You should bring the Y rotation up to about 45. From there, we tried it out in different areas and put on different carts in different classroom settings. And that's how we got to this current form on the largest possible scale in an open classroom. And that brings us to our 3D model that we have today.